Thank you, everybody. I know the time is late. We'll try to keep it lively. so, Dominica this morning started with a point that really struck me. She said high-tech vandals. Like, I really like this way of saying. So, what my presentation is going to be about is how to not be high-tech vandals. So, what I keep seeing in the market are usually solutions that are technologically impressive. Maybe right is not the right word, but impressive is, but they're socially wrong. By socially, I do not mean that they are like funny, they smile to you and stuff like that, the robots, but they do fit in the social environment in which they're supposed to be deployed, which means they fit the problems of the people they should be working with, they fit into the workflows of the companies, and they do actually solve real problems. And fit is a design problem. It needs to be actually designed. So what I do is I am a designer of robotic solutions in terms of experience design and ecosystem. And I chose this field to get into after a career in other areas because this has three aspects that really resonate with me. First of all, I am a psychologist by training, cognitive psychologist, and robots are by nature, even though they don't want to be or they're not designed to be, very often they're perceived as social agents. Even the Roomba that you have in your house that has absolutely no element of anthropomorphism or humanity, let's put it this way, or human elements, you do give it names, you see it wiggle around, you do perceive it as something that interacts with you. So that has to be designed accordingly. The social interaction has to be designed. Then it follows a deep tech market trend, which means that as of now, we are in the situation where the solutions are kind of thrown out there. Before we were talking about 250 humanoids in the market, and how many do actually are deployed? Very little. And the problem is that the novelty of the technology leads. Things are pushed out there because you can, in terms of technological possibilities, but not because you should. And design, it actually helps you understand what should you actually push into the market. And third point is it's a scalable problem. So robots have, some of you said that, an impact on societies. Think about the delivery robots that you find on your streets. What if the streets get flooded by them? What if I am not comfortable enough going out because I'm afraid that robots will bump on me, for example? It's a problem that people do not really think that much about. And on my other side of daily life, I am the head of Designers Italia, which is the design authority of the Italian government, which means that, for example, I work every day with policy, investments, and the sort of structures to bring the full digital ecosystem of the Italian government in the same consistent environment. And robots have to face the same problem. If you do not have policies that will help bring them into the social environment, it will not happen. I'm not just talking about factories, I'm talking like robots that walk on the streets. So robots can be good for different reasons. I'm sure all of you know Atlas. This is the prototype before the one that was presented now at CES. And it has a very peculiar characteristics that you can see in the video. It has a humanoid shape, but absolutely does not move as a human. And this is on purpose. Like I saw a couple weeks back in Edinburgh, they're responsible for human-robot interaction of Boston Dynamics, and we discussed this at length. And the point is they saw that with respect to the competition, the fact that the robot turns, not by turning the body, but by spinning the legs 180 degrees, that is something they would expect in a horror movie and not in reality. Those are seconds saved, and in terms of performance, does matter, because these robots, even though they're humanoid, they're absolutely not made to interact with people. They fully stop and shut down at 2 meters distance between people, with people. So they show you that they will not move as long as you're there. They have a humanoid shape for other reasons. I do not know why they have legs, for example, but the arms I can understand. So their goal was performance. And this kind of behavior, even though it is not a social robot, responds to the need. On the other side, you have Moxie, which is an autonomous mobile robot that is meant to work in human-rich environments on hospital floors. And it brings objects and medications and stuff around the hospital so that nurses do not have to spend time with that. And this kind of solution is not that impressive as a humanoid might be, but it really fits in the workflow. And why it does, I know the designers that work on this, because they didn't start from the shape. They didn't decide, let's do a robot because it's cool, it attracts investments or whatever. They started by researching, like interviewing people in the hospital, doctors, nurses, understanding what is the real problem that they had, and they gave a form to the robot to solve that problem. They didn't know it was going to be looking like this when they started the work. This is and actually the robot itself is made of parts from other companies because that was an easy way to put it together. It's like in a jargon, a Frankenstein. So what does, sorry, it's a little complex to be in front of the slides. So what does good design in robotics decides? So, sorry.
Would you prefer this?
Yes,
Yeah.
thank you very much. So good design in robotics decides what actually should exist. And it's very important that it is involved in 3 main areas. Understanding the strategic fit. For example, you should start by understanding what is the use case that you need to solve. In humanoids right now, and talking about humanoids because it's the hype, the strongest hype, you create the technology, you push it out there, and you hope that someone will find it useful. And then that's why you have 250 humanoids and pretty much 0 in factories or other actual environments. It allows you to understand what is the value proposition. It allows you to understand what is the fit in the ecosystem. So how is structured a factory floor? It helps you to understand what is the business fit and the sustainability. Then you have to design the body interaction. What is the physical form that the robot has? Which are the capabilities, the physical interaction? And this is very important because understanding the capabilities that it needs to solve the problems, it allows you to avoid over-engineering, which is a strong cost. Like putting motors there that you don't really need, it's an expense that you cannot afford. It allows you need it to define the legibility of state and intent, the movement and proxemics. For example, proxemics is the science of space management between people, let's say. So in Occidental cultures, 30 centimeters from your body is intimate space, and you allow people within that space only like on public transportation, for example. This applies to robots as well. And it is cultural specific. So you need to design it because a robot deployed in India is different from a robot deployed in Italy and is different from a robot deployed in US. Then you need to design the lights, sounds, and interfaces to communicate intent, to understand what do you need to communicate, why, and how do you do it. And then you have the human and societal integration. The robot goes into places where people are. So you need to design how do people trust it in time. That is a dynamic element. It's not a fixed point, trust. You need to design what is its role and the responsibilities and how do people understand the responsibilities that the robot has on the factory floor, for example. You need to decide if you want the robot to be towards the end of collaboration or towards the end of substitution. It is a design choice. Atlas is substitution. Moxie is collaboration. It can make sense on both sides, but it has to be a conscious choice. And then you need to study the long-term social effects. For example, there are studies that when you put robots in care homes with elderly people, the way they start interacting with each other changes because they know they have a more accepting social persona that they could interact with. And so they start interacting with each other less. So you need to design that as well. So at the end, the right robot is right depending on the situation. It's not right by itself. And bad design, not doing that stuff that I was showing you before, produces very practical consequences that are both operational, economic, and legal as well. So for example, if the physical interaction with the robot is unclear, like you don't know where to put a payload on the robot, or you do not understand where is an acceptable area on the robot arm that you can interact to move it around, you will have hesitation, and hesitant interactions on the long term get to fewer tasks completed per hour. Like we did a test with Jody Salia that was here before with Alto Robotics, studying like disabling the human-robot interaction parameters on the robot, and we found that people will complete less tasks in an hour, for example, because they needed more time to understand what the robot wanted from them. Then motion and intention are unclear. It brings unpredictability, and so lower trust, operational friction, safety risks. Think about autonomous vehicles. Like with cars, when you want to cross a street, you look at the person inside, you look at their gaze, you search for their gaze, and if they look at you, if they start moving more slowly the car, you understand it's safe to cross. If you do not have that, you might wait for the car to pass. And this is something that is happening in factories with autonomous mobile robots. People, instead of having the robots stop when they're passing, they stop because they're afraid that they will not be perceived. And this is reducing the actual performance of the people on the factory floor. Then you have a problem if robot capabilities are overpromised or unclear, like giving unrealistic expectations will bring to misuse, disappointment, or rejection. There is a reason why many humanoid robots right now do not have mouths, because seeing a mouth will bring the perception that the robot can vocally interact with you in a very efficient way like a human could. But then when you start talking with them and they do not respond with the right timing, for example, you will start rejecting it. You will feel not content with interaction. And then control and responsibility might be unclear, which will bring to misplaced trust or weak oversight. You might think that the robot is more autonomous than it is, so you don't check on it that much, and it makes mistakes, and you don't find out. And you could get even to problems like the skilling. So before we were talking about the apple picking, for example. So what happens if the competence of being able to pick an apple in the right way, but that's just an example, just goes to on the robot, and there's no humans left that have that knowledge. So keeping people skilled to be able to oversight robot actions needs to be considered within the design process. Design is something that is throughout the whole process of the robot. Usually I just see it here in the development part, where you design the form, the shape of the robot, but it has to start before for the reasons that we just seen. So because it helps you understand what is the problem, what is the context, what the users actually need, and what are the risks of the market you're entering. And it allows you to frame the use case, the value proposition, the sustainability, and the success criteria of the solution itself. Then it actually is involved most time on the defining the robot shape, the behavior, the interaction, and the service ecosystem. Also, this is interesting because most times when I talk with companies, to them the robot is the product. The robot is the main touch point of a wider product ecosystem. You have the training process, it has to be designed. You have the technical support of the robot itself. You have the deployment process. You have many other things. You might have digital interfaces to check on the robot at a distance. All that has to be designed. It's part of the same experience. And then afterwards, as well, usually designers or design intent is not involved. You need to validate the solution with real people, like going in like fairs to show your robot with the people passing by and say, oh, cool, I really want it. That's not validation. Also because that is a customer, that's not a user. It's a different kind of persona. And then when you deploy it, you need to keep checking how it works on the factories or in the house to improve it over time. Because adoption is not a deployment moment. It's not that you put it out there and that's it. It's something that happens over time in real use. So you need to be there with design intent as well. A good robotics design process allows you to improve real-world performance, build trust and adoption, lower life cycle cost, for example, for maintainability of a robot that has been designed the right way for the use case that you had in mind, and the risk investments, because you solve the right problem before building the wrong robot. Before, we're talking about like how precise a robot is in conducting a task. Having understood that at the beginning would allow you to avoid building the wrong robot. If you got to that case, it meant that there was no understanding part at the beginning of the process. So design is not an optional layer. It turns robotics from a demo, all the videos that we see of robots dancing or whatever, to an actual viable solution. So to just go towards the conclusion, where is robotics now? So market, we're still kind of in an early market phase where technical possibilities what drive what gets built and gets pushed out there. But as soon as saturation will hit, so those 280 robots will start actually hitting the factory floors, the experience and the design of the whole solution will become what differentiates yourself, your solution, from others. We've seen this countless times. Like with digital products, it happened like that 15 years ago. With AI, at the beginning, like, okay, the model is the more powerful. Now it is the more usable. You turn between Claude and ChatGPT also because they are easier to interact with, for example. So at the end of the day, only the robots that fit are the ones that will be adopted. And as we were saying, fitting means designing the solution in a conscious way, respecting all those parameters that are needed to actually make it a solution. It is very fun to me how we call it a solution, but then it's instead just technology pushed out there and it's not solving anything most of the time. So that's something that should make us think. Thank you.
Thank you so much, Federico.